Okay, so this is a degree of unsaturation problem, and it's not super straightforward because we are actually given the molecular formula without being told how many hydrogens there are, but we are given this information, how many rings and double bonds these compounds have. So uh, we are asked to fill in the number of hydrogens given this information. So we can look at the number of rings and double bonds and immediately get the degree of unsaturation for each of these. So the degree of unsaturation for A, 2 rings and 1 double bond, so that's 3 degrees of unsaturation. This one has 2 degrees of unsaturation, 2 double bonds, and this one has 1 ring and 3 double bonds, so that's 4 degrees of unsaturation. So now let's go back to A here and look at the molecular formula. So this is C8, so this is a C8H question mark O2. So what would be the fully saturated formula here? And then we can, if we look at the fully saturated formula, we can figure out how many hydrogens should be there given this degree of unsaturation. So in this case, it's 3. So the fully saturated, so let me just, fully saturated would be C8H, and since we ignore the oxygens when we're doing degrees of unsaturation, the fully saturated version of this molecule would be C8H. So what is 2n plus 2? So C8, 2n plus 2 would be 18. So the fully saturated version of this molecule would be C8H18O because, O2, because we just ignore the oxygens when we're adjusting the number of hydrogens in the degree of unsaturation calculations. So the fully saturated version of C8 with 2 oxygens is C8H18, 2n plus 2O. And so since we have a degree of unsaturation of 3 here, that means that we have 6 hydrogens that need to be removed. So this would be C8H12O2 with 3 degrees of unsaturation. So the answer here is 12 hydrogens. So let's look at B. C7H question mark N. So the fully saturated version of this molecule would be C7, and if you just do 2n plus 2, you get H16. But when we add a nitrogen in, we need to add another hydrogen with it to achieve the same degree of unsaturation. So, or in this case, to be fully saturated, the fully saturated parent without a nitrogen is C7H16, with 1 nitrogen is C7H17N. So for every nitrogen, we would add a hydrogen here to the molecular formula. Now we have 2 double bonds, so the degree of unsaturation is 2, which means that there are 4 hydrogens missing from the fully saturated structure. So we have C7H, 17 minus 4 is 13N. So that's the answer, 13 hydrogens there. And looking at C here, C9H, and then there's an N and an O. So again, the fully saturated molecule would be C9H. Without any nitrogens or other atoms, it would just be 2n plus 2, which is 20. But with a nitrogen, we add 1 for the nitrogen, so that would be 21. And we don't do anything when we have oxygens. It's the same molecular formula, the same saturation. So C9H20 and H21 NO is the fully saturated molecular formula. We have 4 degrees of unsaturation, so that's 8 H's. And so 21 minus 8 is 13. So the molecular formula here is C9H13NO. So the number here is 13.